A popular game is fruit cutting, which requires the use of a camera and is highly interactive. In the game, a fruit appears that you must cut by hand, actually with any movement in front of the camera, and then another one appears which you have to cut, and so forth. How can we build it? Let's first design the interface. There is one fruit on the screen at a time. Initially, it is the entire fruit, and once it's cut by the user, it is shown split in parts. It doesn't matter what fruit we use as long as there is a bit of variation, say around 3. And we have both fruit versions, the entire and the split fruit. The user is expected to cut the fruit by moving his or her hand in front of the camera, so these movements should be visible during the game. This means that the image captured by the camera should be shown as a stage background. So here's a sketch of the game user interface. Now let's think about the code design. We can decompose the program in two main parts: the initialization of the game and the game progress. The game initialization involves turning the camera on to record so that the user can see him or herself. It also involves starting with some particular fruit, say the apple. So these are the steps during the game initialization. The game progress is the following. A fruit appears at some point of the screen that you must cut by hand, and then another one appears which you have to cut, and so forth. This can be captured like this. Good! We've designed our fruit cutting program. Now let's implement it in Scratch. We'll start with the game interface. Remember that this is what we want the interface to roughly look like. We'll take care of the background within the code for the game initialization. Now let's introduce the fruit. We'll choose various fruit costumes and edit them to have two versions, full and split in parts. Let's start by introducing an apple from the Scratch library. We'll duplicate it to modify it so it looks like it's cut. So we'll click on Convert to Bitmap and then choose the eraser, setting its width as desired, and split the apple in two. We'll then introduce a whole watermelon, and then half a watermelon. We'll also introduce a whole orange, and an orange split in half. Note that we've placed the full and split costumes of each fruit consecutively. Now let's delete the cat and give representative names to these costumes. Remember that it is good programming practice to use meaningful names for each element, so we'll also name our sprite Fruit. Good! We're now done with the different interface elements. Let's move to the actual code. We'll translate the pseudocode for the game initialization into Scratch code. So we'll turn the video on and set its transparency as desired. And we'll set the initial costume to be the full apple. We'll have the following process repeat forever, using the Forever block from the control palette. We first place the object somewhere on the screen. Its position can be randomly chosen with the use of the Pick Random block from the Operators palette. Here, we've given values -100 and 100, but feel free to try a different value range from the Scratch coordinate system. We then wait until some movement on it is detected. To achieve this, we'll introduce a Wait Until block and we'll use a video motion block from the sensing palette to set the weighting condition to be video motion larger than a value, say 50. When such a movement is detected, we switch to the next costume, thus showing the same fruit but cut. Then wait for a few moments. And then show the next costume, which corresponds to the next entire fruit. Let's snap this code stack under our code for the game initialization. We'll also add the green flag. Now let's try it out. Cool, right? In the next video, we'll develop another fun game following the principles of software design.